And now I can go back to initial velocity, predictions, and verification. The only thing that we need for this to complete this assignment is our data set from initial velocity and our verification data set. So what I want to do now is I want to copy both of those from Dropbox into this folder. And so let's go back to Dropbox. And then the blank Dropbox is open. Go to Dropbox here. And go to my folder. And under 6, not 6, under 7, interpolation, you see that we have this file here. I didn't rename it, but we're going to rename that. Let's rename it now. And we're just going to call this our calculator. Rename that. Let's go back and let's go to initial velocity. All right, here is initial velocity. This also should be in your initial velocity folder. So let's just copy that and let's take this to our interpolation folder and then paste it. Then let's do the same thing for our predicting the range, because this is just data. If you want to double check it, you can just look at it and you'll see that it's just a data set. So I'm going to go ahead and say copy, and I want to copy this to our interpolation folder as well. I'm just going to paste it. So now that all of that is done, if we go back into interpolation, we'll see that we have our 2 data sets, which we need, and we have our calculator. We're just going to put these 2 data sets into our calculator. So let's go back to Microsoft Excel, and you'll see, let's start off with initial velocity. So I want to go into the folder from Microsoft Excel. And the reason why is because when I go into it from Dropbox, it keeps taking me back and forth through Dropbox. So just going to copy our X and Y because that's what we need. Going to go to the calculator. And under initial velocity, you'll see we have X and Y here. I'm just going to paste. And if you look at it, you should have numbers that are the same. So this is, I have 3.1. Don't change, don't mess with this stuff. This is calculated for us, as well as these averages over here. So the X displacements are calculated and the averages are calculated. Now we need our verification data. If I go over to incrementation, you'll see that it's getting closer to incrementing, but we still are not incrementing properly. And our graph is not quite right yet, all right? So it's not quite right. So let's go to our verification data. Let's go back to our folder and get predicting the range. I'm gonna go to X, Y, copy, go back to our calculator, just like I said before. Then let's just paste this into X and Y. So paste. So you'll see that the data is still going down below this axis here, but that's okay. We have our prediction. We have 0.84. All of that is still working the same. Our prediction is fairly low. I mean, our percent difference is fairly low. And this has to do with precision. So if we go to increments now, you'll see that we're incrementing pretty nicely. And this is basically 2.6 millimeters for each increment. For every degree that we go up from 0 to 1, we're going 2.6 millimeters. And we're going to do that all the way up, okay? And you'll see that we're calculating our range as it goes up, all right? This actually says that it's 90, but it's only because of the decimal places. So let's increase our decimal places to 4. And I should have decreased this one to 4. All right, and you'll see it's incrementing nicely here. Now, what's interesting is this should not change. This, oh, it didn't. It is a calculated range. And we have our measured range here. And we have our measured range at 20 degrees, our measured range at 0 degrees, and we have our percent difference. This is our precision. And we're just going to go over to our graph, and you'll see that our graph it has a, what do we call this? We call this a y-intercept here, and that's at 0 degrees. And then we go on up to 20 degrees, and it's ending very close to 90. And this is our calculated range. It's not our actual measured range, but it's our calculated range. All right, so there's error already in it, and it's getting wider and wider out here at 20 degrees. Well, that's the end of this talk here, and I'm just gonna go ahead and in the next experiment we'll explore this further.